Let's look at this problem. We have this 20 kilogram wheel. The radius of gyration about its mass center is given. That's good. And the wheel is subjected to a couple moments and it slips as it rolls. We need to determine its angular acceleration as well as the linear acceleration of the wheel's center. We are given the coefficient of kinetic friction between the wheel and the plane. So for this right here, if we analyze the motion, because it is rolling under a couple moments, so as you can tell, at the point of contact, the impending motion is actually to the left. As a result, the frictional force tries to resist impending motion, therefore the frictional force is to the right. And the friction is already given as kinetic friction, and that can be evaluated as mu kn. So with that said, now let's start drawing the free body diagram. So for the free body diagram, we have the weight of the wheel, that is 20 times 9.81, and it is subjected to couple moments, 100 Newton meter, normal force, and also frictional force. For its kinetic diagram, this is point G. We know that when this wheel is rolling, its mass center only has horizontal linear acceleration to the right. And also because it's rolling clockwise, this is the IG alpha. So in this case, point G is the same as point O. So these two are the same. Let's call it point O to be consistent with the problem, even though it is the gravitational center. So now we're ready to write the equations of motion. So again, don't forget this is the general plane motion. This is not translation. This is not rotation about any fixed axis. So resultant force along the y direction, we do this first because we want to solve for the normal force. That equals to n minus w, which is 20 times 9.81, and equals to 0. There's no vertical motion. So from there, we can easily evaluate the normal force to be 196.2 Newton. And from there, we can also evaluate the frictional force. We already know it is kinetic friction, so mu kn 0.5 times 196.2, and that equals to 98.1 Newton. Resultant force along the x direction, horizontal to the right, we have the frictional force 98.1. That's only horizontal force. On the right hand side, we have ma, G equals to 20 times a. So from there, you can already solve for linear acceleration, which is 4.905, so 4.91 meter per second squared to the right. Lastly, we're going to summarize the moment about point O. So we have the let's say clockwise is positive, because we can tell that the wheel is rolling clockwise. So we have the positive 100 Newton meter couple moment, and then the frictional force is creating counterclockwise moment about point O. So minus 98.1 multiplied by the moment arm. The moment arm is the radius of the wheel, which is 0.4 meter. On the right hand side, we have IO alpha. Keep in mind that here IO, point O, is the gravitational center. Therefore, IO KO squared alpha, and that equals to 20 times 300 millimeter is 0.3 meter squared alpha. So from this last equation, we can solve for alpha to be 33.8 radian per second squared. So that is the angular acceleration of this wheel. And we have also determined the linear acceleration of the mass center.